हरि करना।
Now let's look into the one more very important distribution, which is T distribution or students T distribution. The T distribution is normally shaped distribution, except that it's a bit thicker and longer on the tails. It's used extensively in depicting distributions of sample statistics. So, distribution of sample means are typically shaped like a T distribution, and there is a family of T distributions that differ depending on how large the sample is. The larger the sample, the more normally shaped the T distribution becomes, and this is nothing but your central limit theorem. As the sample size increases, it approximates to the as the sample size of sample as the sample size increases, the sampling distribution will approximate towards the normal distribution, and this is called central limit theorem. That's what we are trying to say here. The larger the sample, the more normally shaped the T distribution becomes. So, students, T distribution is a probability distribution that arises in statistical inference when the sample size is small and the population standard deviation is unknown. When these conditions are there, when we do not know the population standard deviation, and when we do not know the size, when the sample size is very smaller, so in this case we will go with the students T distribution. In most of the cases you will not know the standard deviation of the population, because you will never be doing the survey on obviously your population. You will never do the complete survey on the population. You will take a sample, and on the sample you will be doing the survey. So that's the reason most of the cases you will not be having the population standard deviation. So that's the reason the students T distribution would be used widely for respective tasks. So it is used to perform hypothesis testing and construct confidence intervals for the mean of a population. The T distribution is similar to the normal distribution in shape, and but it has heavier tails, which means that extreme values are more likely to occur than in a normal distribution. When we say it will have a heavier tails, which means that extremes values are more likely to occur than in a normal distribution. So heavier tails are nothing but high probability on here, on ends. So that means the extreme values would be little higher than compared to the normal distribution. That is the main difference between the normal distribution curve and then students T distribution curve. Okay, the extreme values are more likely to occur more in T distribution than compared to the normal distribution. So the T distribution has a family of probability density functions that depend on a single parameter called degrees of freedom. Very, very important. Very, very important. Degrees of freedom is which is positive integer representing the sample size minus 1. So what is degrees of freedom for now? It's pretty simple. It's n minus 1. That's a sample size minus 1. Exactly what does it tell? How does it make sense to a data science? That we will discuss later. But for now, degrees of freedom is nothing but n minus 1. And this is what the probability density function of T distribution. You got the gamma of df, degree of freedom, plus 1 divided by 2 whole divided by square root of then df pi and gamma of df by 2 multiplied by remaining function. So this is what the probability density function of students t distribution. So this formula, the formula for probability density function of the t distribution or students t distribution with df degrees of freedom is given here. You can see on the screen, where gamma is the gamma function and t is the t is the, you can see the t here, the t is the random variable that represents the sample mean. So t is the random variable that represents the sample mean. So the t distribution is named after William Gosset, who wrote under the pseudonym student. So he developed the t distribution to solve the problem of estimating the mean of a population when the sample size is small and the population standard deviation is unknown. From there, the t distribution has become students t distribution. So the t distribution is often called students t because it was published in 1908 in Biometrica by W.S. Gosset under the name student. So Gosset's employer, the Guinness Brewery, did not want competitors to know that it was using statistical methods. So it insisted that Gosset not use his name on this article. So Gosset wanted to answer the question. So what is the sampling distribution of the mean of a sample drawn from a larger population? That's what the main agenda behind creating this. So let me put it here. So sam t distribution or students, let us respect that guy. Students t distribution. T distribution. So the main agenda of creating all this is to answer the question, what is the sampling distribution of the mean of a sample drawn from a larger population. So he started out with a resampling experiment, drawing random samples of 4 from a data set of 3000 measurements of criminals' height and left middle finger length. So this being an so I'm talking about this being the era, like when this guy in 1908, this being that era, that 1908 being the era of eugenics, there was much interest in data on criminals and in discovering correlations between criminal tendencies and physical or psychological attributes. So Gosset plotted the standardized results G score on the x-axis and the frequency on the y-axis separately. So he had derived a function known as students t on the y-axis separately. So students t, and he fit this function over the sample results plotting the comparison. So a number of different statistics can be compared after standardization to the t distribution to estimate confidence intervals in light of sampling variation. So consider a sample of size n where, let's consider a sample of size n, uh, n for which the sample mean x bar has been calculated. If S is the sample standard where deviation, 90% of confidence interval around the sample mean is given by a formula called x plus or minus t n minus 1 multiplied by 0.05. multiplied by s divided by square root of n, and this is what we are gonna see in the next slide. So this is some history behind why this t distribution has come and everything. So now let's look into the calculation, how we do t distribution calculations. So the t distribution, let's look into the calculation now. So calculating the t static and degrees of freedom in statistical analysis.